So we have had facts. Facts are things that are simply true. Concepts, structures of facts. And now we come to principles. Principles are concepts in action. They're systems. They're things that are moving. There goes into's and comes out's. There's causes and effects. And when we're talking about systems, we're talking about explaining and predicting what happened, why did it happen, what's going to happen, why will that happen, what went wrong, how can I fix it. These are principles, if-then statements. If this is the input, what will the output be? If-then. Or, under what conditions? If I have this condition, I'm going to get this output. If I have that condition, I'm going to get that output. With principles, when you're teaching principles, you are teaching how a system works. So, this is great for a simulation. This is really ideal for a simulation. And remember when we talked about simulations, you don't necessarily need physical fidelity. It doesn't need to necessarily look and act like the real thing. What's important is cognitive fidelity, so that you're thinking the way that you would when you're dealing with the real thing. And if you look at my video on simulations or read the Plato Memories essay, that talks a little bit more about simulations. So when you have a system, you want to teach the components of the system, at least to the extent that that makes sense. It's okay to have a black box. So you have an input, you have something mysterious that happens, and then you have an output. And if it's not important to understand what's going on inside the black box, it's okay to leave it to be a black box. Now remember what we said about facts and chunking? So we have an input, we have an output. Let's open up the black box. Inside the black box are several other black boxes. So if you have this kind of input, it operates on this black box, and then you have an output. If you have this kind of input, it operates on that black box, which goes to this other black box, and then you have an output. And if you have this third kind of input, then it goes to this black box and has that kind of output. So now we have sort of this understanding of what's inside the black box, and now we can drill down another layer and look in this first black box and open that up and find out what happens there. And then look in the second one and see why it has to go to the third one. So you take it step by step. You can chunk systems the exact same way that you chunk facts. And in a sense, they're really quite related. So if you're understanding physiology, if you're trying to learn physiology, which is how the human body operates, well, you've got to understand some facts about the components of the system, your anatomy, but then you have to understand how they interrelate. And so the heart pumps blood to the lungs. The lungs put oxygen into the blood and take carbon dioxide out of the blood. So you get it at a big picture level, right? You learn this in, I don't know, 5th grade, 6th grade, something like that. But it's not until you get to college that you start to learn about arterioles and, I forget the word for the tiny little air sacs, and then the names of the cells that make things up. I mean, if you take a histology class, so you're looking at lung tissue and you can tell if it's cancerous or non-cancerous, or if there's pneumonia or what have you. So you get down to greater levels of detail with the system. Now, if you studied your learning theories and you read about Jerome Bruner and the spiral curriculum, or the onion model of a curriculum, right? You teach things at a very high level, at a gross level, like big picture stuff, and then you get down at further levels of detail. It works exactly the same way. So, teaching principles. If then, goes into's, comes out's, concepts and actions, systems, explain what happened, predict what's going to happen. And this is really, really important, and it's usually overlooked. Failure and recovery. What can go wrong? Where can it go wrong? What are the danger points where something might break? And if something goes wrong, how do you recover? Remember in the simulation video I was talking about the DC-9 APU, the auxiliary power unit video, right? A big problem was the guys starting them up would do things out of sequence and set them on fire. So if that goes wrong, how can you tell that an error has occurred, right? This warning light blinks on the panel, and then what do? Well, you activate the fire extinguisher. Okay. Learning how to recognize and deal with failure modes is a really important part of dealing with systems. So don't leave that out. Systems, principles, concepts in motion, explain and predict, failure modes, and recovery. Very important. Don't leave that out.